Hi everyone, today we are going to be decoding your GCSE periodic table. Now there are a number of periodic tables that you'll come across if you just stick it into Google, but it's really important that you're familiar with the one for your exam board, so for GCSE, because it's going to be your best friend during your exams. There's no formula sheet like you've got with physics. This is what you are going to get. So in this video, I'm going to be going through the key concepts, the key different fundamental pieces of information that we can get from the periodic table. Now, don't worry if I'm just touching on each of these concepts. There are going to be videos on each of them in detail. So make sure that you are subscribed so that you can see those videos when they come out. Now, the first and hopefully simplest thing for us to spot or for us to identify is where are our metals and non-metals. Now, there is a line which is called the amphoteric line for reasons that you'll find out about in A-level, where we separate our metals and our non-metals. Okay, that is not perfect, but roughly we have got our metals on the left-hand side, and then we have our non-metals on the right. Now, if we now zoom way into individual tiles of the periodic table, so let's just draw one over here. I want this one. Okay, let's zoom all the way in so that we know what pieces of information each tile is giving us. Okay, what is that? Let's say that that's sodium. Okay, I've decided. Is it? Yeah, close enough. Okay, so if this is sodium, there will be the symbol. Now, any chemical symbol must start with a capital letter. And if there is a second letter within that symbol, then the second one is lowercase. So what I hope to never see, and what I hope you never put your teachers through, is writing something like this for sodium, okay? Because that is very, very wrong. Nah, indeed. Okay, so we have got our symbol, capital letter, and then lowercase letter, and then there'll be two numbers in here. The number at the bottom will be the atomic number. Now, the atomic number tells us how many protons are in the nucleus of an atom. So in a future video on atomic structure, we'll talk about where our subatomic particles live, but just very simply, in the center of our atom, we have a nucleus, and that nucleus will contain 11 protons because the atomic number is 11. The second number that's given to us in our periodic table tile is the relative atomic mass. Now, the relative atomic mass, which is also given the symbol A with a subscript R, tells us the average weighted mass of all of the isotopes that exist of a particular element. Okay, now, this number at the top, the relative atomic mass, is not the same as the mass number. Okay, the mass number tells us the number of protons plus the number of neutrons. That is not the same as the relative atomic mass. If you wanted to find out the mass number, you wouldn't look at a periodic table tile. They would have to tell you in atomic notation, where it looks more like this, with no square around it, okay? Then this is the mass number, okay? Very subtle, but very important distinction. So we've got the relative atomic mass, we've got the atomic number. Now, because atoms of elements are neutral, if we've got 11 protons, which are positively charged, then the atomic number also tells us the number of electrons. So if there are 11 protons, there must also be, I'm gonna get rid of this for now. There must also be 11 electrons. Now, those electrons are arranged orbiting the nucleus. Again, we'll have a whole video on electron configuration. Wow, what a big atom. Okay, we'll have a whole lesson on electron configuration at another time, but essentially we're going to have 11 electrons, and we follow a rule which is a 2-8-8 rule. So the first 2 electrons are on the shell closest to our nucleus. Then the next 8 will go on the next shell further away. And then that leaves us one more electron to go on the outer shell. Okay, so again, the tile will tell you the atomic number, which is the number of protons. Because atoms are neutral, that's also the number of electrons. And we can also figure out the relative atomic mass, which we'll need later on in our moles calculation. I can see a whole moles series coming. Okay, now, just the periodic table tile alone does not tell us the number of neutrons. So I'm not going to write it in here because the periodic table actually doesn't tell us that. We would need the atomic notation. Okay, now we've got an individual atom. Let's come back to the whole periodic table and see how the structure of the periodic table can give us some more information about our elements. So our periodic table, how many times can I say periodic table in the same video? Probably a lot more, seeing as that's the title of the video. The vertical columns are called the groups. So we got group 1 and group 2. We don't think about at GCSE, so we don't number these groups in the middle, okay? These are our transition metals. Okay, they follow their own rules, and anybody that's doing triple science, we talk about the transition metals in a bit more detail. But for now, when it comes to numbering the groups, we've got group 1, group 2, then we skip the transition metals, and then we start numbering again from 3 when we get back to the next main part. Do I have enough space? Just about. Up here, this group, the final one, sometimes you'll see it called group 8, sometimes you'll see it called group 0. Now, the group number tells us something very, very important. Maybe, in my opinion, the most important thing when it comes to bonding and reactions is that the group number, where can I write it? Let's do it over here. So the group number tells us the number of electrons on the outermost shell. What does that mean? Well, if we come all the way back to our lovely diagram of our sodium atom, sodium is in group number 1. So how many electrons do we expect to have on its outermost shell? Well, just 1 electron. And that indeed is the case, just 1 electron on the outermost shell. If we went over to group 2, 2 electrons on the outer shell, group 3, 3 electrons on the outer shell, and so on and so forth. Now, the reason that is so important is because if we know how many electrons are on the outer shell, then we know how many electrons it needs to lose or gain to have a full and stable outer shell. And as a result, we can learn a lot about ionic bonding and the ion charges that it will form. We can also understand a lot about covalent bonding as well and how many electrons it will need to share. Okay, so again, group number, so important. When it comes to the horizontal rows, do I have another color? Yeah. When it comes to the horizontal rows, these are called the periods, like the periodic table. That's where it comes from. So those are our rows. Now, to be really, really careful, period 1 does not start here. Okay, and that's because up here at the top, even though there are only 2 elements in period 1, we have got hydrogen, and we've got, pretend this goes a little bit further, helium. Those are in period 1. That is our first period. And then when we come down to lithium, that is actually period 2. Okay, and then 3, 4, 5, and so on and so forth. Okay, so our green, those are our periods. Now, once again, the period number can tell us something quite important, less important in my opinion, no offense, than the group number, but still linking back to electron configuration and the arrangement of electrons. The period number tells us the number of occupied shells. So how many electron shells have actually got electrons in them? So for example, sodium has got one shell, the one with the two. Oops, where am I going? With the one with the two, then a second shell, the one with the 8, and then a third shell, the one with the 1. So 3 occupied shells, therefore sodium is in period 3. Okay, again, less useful when it comes to bonding because we care more about the valence electrons or the electrons on the outer shell that are involved, but the number of periods can tell us a lot about the reactivity because as we go down any particular group, if they have the same number of electrons on their outer shell, then they are going to have similar reactivity. But depending on the number of shells, so the period number, that's going to affect how reactive they are. So they might react with the same things, but one might react very slowly, very calmly, and then something else might react very, very vigorously as we go either down the group or up the group, depending on where we are. And we look at that in detail in your course when it comes to group 1 and when it comes to group 7. Okay, that is the key information that you need to know to get the most out of your periodic table. So your very new, or maybe not new, your best friend when it comes to your chemistry GCSE. Now, for future videos where I go through each of these concepts in depth and for more chemistry GCSE tips, make sure that you have liked, commented, and subscribed so that you see those future videos.